Hey gents, this is the first of Unit 7. We're going to be talking about dimensioning standards again. Some of this will be familiar to you, some of it will be review, and some of it will be all new information. I'm going to go through it kind of quickly, so pause as needed. So first off, dimensioning standards have been established by universal or centrally located organizations. These organizations and companies will follow a set of standards that are accepted by other companies so that everyone knows the same set of rules that are being followed. It just makes things more streamlined. We know that a pound is a pound here and in California and in New York because we've all agreed on a set of standards in which a pound is a pound. That's just one example. So we have these different particular organizations. We're going to talk about a few of them and then we'll move on. So the first one is ANSI, the American National Standards Institute. Again, it's mostly engineering standards in North America, universally accepted set of rules. ISO or ISO is the international organization. This is worldwide. There are a lot of countries that participate in this. America also participates in ISO for a lot of things, but again, it's just a agreed upon set of rules. Then we have the DoD, or the Department of Defense, and the military standard. So the DoD and military standards are going to be used obviously by the military and the Department of Defense, but also by any corporation or company that makes things for the DoD or military so that they have agreed upon sets of standards. So if company 1 is making something and they say it's going to be 1 inch in diameter, and company 2 is making something that has a hole for that part to fit in, it will actually fit. Then we go on to just some of the other ones. There's the German Standards Institute, the Japanese, and the European Institute. So again, it's just a set of rules followed by people agreeing to this set of rules. Let's get back into actual dimensioning. So we have some components. You should be very familiar with these. We've got our dimension text, which is just going to tell us how big something is. Your dimension lines, which are going to be on either side of your dimension text. There's going to be an arrowhead at the end of the dimension lines to indicate, hey, the dimension starts and ends here. And then finally, there'll be extension lines that run from your dimension lines down towards the object being dimensioned but not touching it to specify that this is the part parameter where the dimension is actually starting. Some of the guidelines for text. The text should always be in between the arrowheads, both vertically and horizontally. It can go outside of the arrowheads if the text is too large. So like here, this one is too large to fit inside of its arrowheads, so it can be placed outside the arrowheads with a little extension line right here indicating, hey, this number belongs with that dimension. Right, like I just said, the text should be in the middle both horizontally and should be in the middle vertically. This just keeps things consistent and neat. Otherwise, you end up with text all over the place and it just looks very, very hard to read and very messy. Okay, now we have been so far only using unidirectional. We can put the text in our dimensions in 2 different ways, unidirectionally or aligned. So in unidirectional, that means that all of the numbers or the text is running right to left or up to down in all parts. I prefer unidirectional, the way that we read, running right to left. Some people prefer other methods. The aligned method means that the text is aligned with the direction of the arrowhead. So it could run right to left or up and down. And I'll show you what I mean here. So here we have unidirectional, where all of the text is running right to left, no matter what direction the dimension is. So this dimension is a right to left dimension, and this is an up to down, but all the text is running right to left. Over here, on the same drawing, if we look at our height text, they're turned 90 degrees, and they run along the same direction as the arrowhead. So they're aligned with the arrowheads. It's a matter of personal preference. For our classes, I would prefer, unless I specifically tell you otherwise, that you use unidirectional. It's just, in my opinion, easier to read. You'll remember that there are a couple different types of dimensioning that we do. We do both both size and location. So I need to know how big something is. I also need to know where it is located. So size dimensions are telling me how large it is, where location is giving me coordinate points as to where the feature is located on the object. So if we look at our example here, we know that the dimension between these two center marks is 1.83. That is a size dimension, but I know that this center mark is located at 0.61 units from the edge. So that's a location dimension. You should be familiar with these. We've been using them a lot. Now we're going to go on to some specific names for the way that we dimension things. Okay, sorry. So we have chain dimensioning, and this is where we dimension from one feature to another. It's commonly used, but there are some problems with chain dimensioning. So in chain dimensioning, and here's what it looks like. You start at, say, the left edge, and you do a dimension, and then you dimension from that point onto the next one, and from that point onto the next one. So you get this like 0.5, 0.5, 0.5. The problem with this is say that this first dimension is slightly off. It's supposed to be 0.5, but it's 0.9. So now our next dimension is going to also be off because we're measuring it from this edge, which could be inaccurate. So the inaccuracies accumulate and build upon each other over time. We could end up with this, we could end up with this entire part being way too short or way too long because we've just added on to it. Another form of chain dimensioning is where you give the overall dimension and then you chain a few of the dimensions inside. We've used this one quite frequently. This will eliminate some of the manufacturing inaccuracies because we know what the overall should be. We're not going to have the entire part be too small, but we still can get some inaccuracies, but just not nearly as many. So if you're using chain dimensioning, you should be using the method 2. I have taught you guys always include an overall width, length, and height. So you should have a default of using this method too. The next dimension type we have is called datum dimensioning. And in the case of datum dimensioning, we are dimensioning from a single start point. So say like the left edge of a part. All of our dimensions will emanate from that part. This is good because you're not going to have manufacturing inaccuracies. You might have one dimension that's wrong, but not any two that are going to build upon an error. So this is a good way to do dimensioning as well. The datum is the name we give for that point where you're going to start all your dimensions. And let me show you what this looks like. So in this case, we are saying that this corner right here is our datum. All of our dimensions are going to start from this point. So you can see I've started all 3 of my width dimensions from this edge and all 3 of my height dimensions from this edge. So all the dimensions emanate from a single point. They aren't built upon each other. So if we make a mistake, say with this first dimension here, this next dimension and the third dimension are still going to be correct. This part, this cut here and this cut here would be right. It would only be one that would be inaccurate. Okay, here's some of the dimensioning symbols. We're going to talk about each one as we hit it. You should be familiar with most of these symbols. The degree symbol, reference symbol, diameter and radius. We've used those a lot. Our counterbore and countersink, which we'll talk about when we get to the whole notes in 7.2, along with the depth symbol. Remember, places means if I'm dimensioning, say 3 or 4 holes on a part, I can just dimension one and say times or places 3. So I would know, all 3 of those holes have the same dimension. And then these dimensions up here are not commonly used. We probably won't get to them except for the plus and minus. Okay. Let's talk about a couple of the special types of dimensioning and situations that we haven't done yet this year. So angled surfaces. There are 2 ways in which you can angle or dimension surfaces. I have taught you how to do one of them. I've taught you the coordinate method. You can also use the angular method. So in the coordinate method, instead of trying to figure out what the angle of this angled line is, we're just going to say, hey, it starts at this point. So I know it starts at 0.88 from the left and 0.1 from the height. and it ends here at 1.75 in length and 0.5 in height. If I just start and end my lines at those 2 points, my angle will be correct. So that's one way to do it. The other way you can do it is by actually specifying the angle. So we know that this is where it starts along this edge here, and this is the actual line. I just measure the angle between the two and I specify that angle. Either method is fine. I don't really have a preference. I tend to use coordinate just because it's a little cleaner looking, but either method is fine. All right, now we're going to talk about dimensioning chamfers. Again, there's a couple of ways to do this. You can use the angle method that we just talked about, or you can have Inventor tell you the degree. So 45 degrees times what the length is, and then you can just plug that stuff into the chamfer feature. If when you're dimensioning, you just hover over the chamfer, the mouse will change to, I believe it's a little circle, and you drag away, you'll get your chamfer dimension. We're going to use the same type of stuff if we're doing, in this case, this is looking at a hole where it will give you the angle, or, a cut in angle. So let's look at a couple of these and how to read them. So there it is telling you it's a 45 degree with the dimensions, and here it's telling you the other degrees with the dimensions, and these are the interior degrees with the chamfer dimensions. Next we have arcs, and this is a lot of information. Basically, it's just saying that we are going to dimension arcs. It's basically saying that we are going to have center marks and radiuses or diameters specified. Let's just look at some examples so you can see how it's done. So here we have a little object that's got 2 arcs and what would be a circle. So we've got, let's look at this big one here first. We've got a very large arc, almost a half circle, and there is a center mark placed in this. So make sure that you put your center mark in. And then we're just measuring the radius off of that center mark. Remember, the capital R is radius. On these little arcs, which could be an arc or it could even be a fillet, we're just going to put in the radius, right? And again, when you're dimensioning things, if you just hover over it, like right about here, your arrowhead for your mouse is going to turn to, again, I believe it's a circle. You click and drag out, and it will give you the radius for you. You don't have to try to remember it or calculate it. So it's pretty simple. The same thing is going to be done on fillets and on internal fillets. So in this case, we put center marks in because these arcs are pretty large, and we just clicked on them and dragged out, and it gave us our radius. Remember, the capital R is radius. So this is the radius in degrees. Now, when we are dimensioning full circles, you must put in center marks. And remember, there's an annotation feature on the drawing file that allows you to do that. You just choose it and hover near the center. It turns green, and you click it. When we are dimensioning our circles, all you have to do is choose the dimensioning tool. You'll hover on the edge of your circle and click and drag away, and it'll give you the diameter for you. Full circles, we're going to get diameters. And then in this case, we've got a diameter along with a depth. That's what this little down arrow means. And then right here, what we've got is just a positioning telling us that it's 1 inch between these 2 circles. Another way to do circles, if you've got a lot of them in like concentric circles, is to turn them sideways and do a dimension such as this. You could do leader lines out telling us the dimension of each one of these circles. That would be fine. But if I look at this one, I could do the dimension of each one of these circles, and then I could do along the top, I could do a width, and that would be all the dimensioning that I would need, because I would know how big each one is around and how deep each one is. I could also, and if I had this drawing, I could just draw this shape right here, put in a center mark, and revolve it to make it very, very simple. To do splines and curves, right? If you remember this is what the windshield from the AutomoBlock look like? We can, excuse me, we can use datum dimensioning. All right, so we have done a datum dimensioning from here, and we're going to put in coordinate locations along the curve as it's going. All right, so you put those in. We use construction lines to put in those dimensions, and then you just connect them all either using a spline, or you start a curve here and you go to each one and add a curve in, and it'll give you the overall shape that you want. So this is datum dimensioning for a coordinate location. Here's just another example of one, the actual AutomoBlock windshield that we did. If you guys remember, we didn't get all of these dimensions. We had one right, I think it was right about here and then down to the edge, and we just put in the curve and it gave us the appropriate curve, but we were using coordinate method from a datum to do the same thing. Okay, next up we have, what do we have here? We've got some reference dimensions, and this is what I was talking about, the times x. In this particular example, we have 2 circles or 2 holes cut into this block. Rather than putting all of this dimension information on both of them, I am just saying, hey, 2 times all of this, meaning both holes on this object have the following dimensions. And we'll talk about these types of dimensions when we get to the holes in 7.2. And we are almost done. Last one we've got here, guys, is for patterning on a round object. You are going to, in this case, we know what this inner circle dimension is. Right here, it's a radius of 0.69. And we know what the outer circle is of 2.25 diameter. It's odd. It should be both diameter or radius. But then we're given the degree angles between each one of these holes. So that's how we know where to place them. So we've done this before. We drew some construction lines in. We dimensioned the construction lines. Then we had a little point right here where these lines intersected, and that's where we placed our hole. All right, guys, so that is dimensioning in a nutshell. Remember, datum dimensioning, chain dimensioning. We prefer datum. It's a little bit more accurate. Go ahead and start on activity 7.1. There is a second video to help you refresh yourself on how to do dimensioning on objects and also how to add in additional sheets. So please watch that. That's around 6.5 minutes in the video. If you don't want to watch the whole thing, please check out that. Have a good day.